Hi, everyone. Let me allow everybody to ask questions and chat. Okay. Everyone, let me see. There is some option. Attendees can chat with host and panelist. And chat with everyone. Hi, everyone. Wonderful. Wonderful. Feel free to, use the chat to discuss. And yeah. Salil, you can share the screen as well if you want.
Yeah, just 1 second. My computer's glitching.
Perfect. Perfect. Welcome, everyone. This event is being streamed on YouTube, LinkedIn, and X or Twitter. So there won't be too many attendees in the Zoom meeting. Only few people are going to be in the Zoom meeting, but most of the people will be across, the YouTube channel and other things. Okay. So, great. And in case you are wondering that what is the Zoom meeting link, in case you are on some other platform and wants to join the Zoom meeting, I'm going to just, share the URL for the Zoom meeting with everyone. And if anybody wants to join. Perfect. Feel free to ask questions. The format of these events are going to be more question answer related, oriented, instead of monologue. We want to keep it more discussion oriented. All right. So, yeah. I guess this mic should be better. Okay. I hope you guys are able to hear me clearly. Let's start. Keep it more Q&A related, and I'll be answering your questions related to any of the uh, you know any of the topics: machine learning, AI, large language models, fine tuning, creating your domain-specific LLMs. Perfect.
And can you hear me?
Yeah.
Awesome. Hey guys, welcome to today's session on emerging architectures for large language models. It is going to be more of a Q&A kind of a session. I am having computer glitches, so I might just drop out and restart and join you guys back in. But I will have that sorted in no time. The other thing to point out is that we have lots of folks joining us from around the world. We have people joining us from Toronto, people joining us from San Francisco, from Vancouver, from Singapore, as well as from India. So welcome to everyone. And I will let Sandeep share his screen. I'm just going to restart my PC and I'll be right back.
Perfect. Perfect. So wonderful. So before we start, there is a question, and let me answer the question first. Let's just start from there. A question from Bharat is, will a link to the recording be shared with the attendees? Yes, we'll try to share the recordings, but stay in the call so that you can ask lots of questions. And yeah, so don't worry, we'll be sharing the recordings, but it'll be good to have your, discussion. So feel free to ask your question. That'll be more important. Okay. I want to keep this discussion extremely candid and extremely, uh, you know, mm, uh, discussion oriented rather than monologue. I'll just keep it very discussion oriented. So feel free to ask questions, chat, and if possible, feel free to introduce yourself using the chat. And yeah, good, wonderful. And I will try to see if there are questions on other platform, and we'll keep that open somewhere here. All right. Yeah, there are no questions on YouTube. Perfect. Perfect. Now, a question from Eric is, how would you taxonomize or categorize modern type of LLM? Okay, good questions, good questions. But the first thing that we need to look at is why do we need to taxonomize, right? One reason is that there are just too many of LLMs right now around, and we need to, create a category. But the most important part about the LLM, whether it's Google Gemini, or OpenAI ChatGPT, or open source one, the underlying principle for all of these, the way they have been trained, is similar. Okay, there could be differences in the data set, but the principle is similar. The only thing that differentiates one LLM from another is, number one, how big the model it is. Number two, the efficacy of it and the performance of it. Okay. Good question. I'm just thinking that how would I categorize? The other thing I would do is that I would probably call it, right? I would put LLMs. One is based on their performance. So there are quite a few, the question answer benchmarks, quite a few benchmarks against which the models are being trained. And on Hugging Face and on many places, you will see these benchmarks being updated. So one way to distinguish one model against another is by using these benchmark. That is one. Second way to do is probably the open source versus closed source. Okay, that will be the thing. Now, most of the remaining aspects, like whether you're building a search engine, or you're building the chat agent, or you're using an LLM for sentiment analysis, or you're building your own machine learning models, or you're building domain-specific AI solvers, all of them are basically built upon similar, like they all utilize the same similar LLMs. Okay, so I mean, it's easier to distinguish the architectures. It's easier to categorize architectures, but most of the LLMs under the hood have the same principle. Okay, good, very good question. And all right, let me onboard. Okay, just give me a moment. Okay, let me add Salil. Okay, perfect. Very good questions, and keep these questions coming. Okay.
Hey, sorry.
Hey, hi. There are quite a few questions to get started, and yes, a question from Bharat is that Databricks has come up with their open source LLM recently, and that is being described as the most powerful open source LLM. However, it is significantly bigger model, close to 130 billion parameter, than say Mistral 13 billion, 13, which is basically 1/10 of the size of the Databricks one. Please share your thoughts on which ones are the most powerful LLMs weighted by their size from your experience. Good question. Good question. So in a machine learning model, or for that matter, any intelligence, the way to judge a model quality is by their answers. When you let it be tested on the similar benchmarks, that's where the you know the model is judged. Model should not be judged only based on the number of parameters it has. Okay, of course, a model with more number of parameters has more capability to memorize or more capability to learn. But at the same time, when you have a larger model, if it is not trained sufficiently, or if it is not controlled and regularized sufficiently, it would have enormous tendencies to memorize. Okay. And so essentially, having the large model is not the only criteria. You cannot judge a model by its size. You should only judge the model based on the question answer, like the quality of answers it's giving on Vicuna dataset or some other benchmarks.
Yeah, and to add to what you just mentioned, so it's completely use case dependent, right? Like, what is the problem that you're trying to solve? That's number one. Second, you are running evals on that particular information. You're trying to figure out, is this doing the thing that we want to properly or not? And uh, to add some more value to this, DBRX is, yes, like Bharat mentioned, it is 132 billion total parameters, but it's a mixture of experts model. And at any given time, they're using just like 36 billion parameters. So it is fairly comparable to like a smaller model, but like you mentioned before, it does depend effectively on how you are, what your use case is, and what the LLM performs in evals for that particular use case.
Yeah. So yeah, I think of course, it's a very hard thing. Okay, it's a very hard thing to say. Like, it's not necessary that a really intelligent person would have larger brain than the other person. Okay. Um, it is not necessary. And basically, like I ask this hypothetical question to many people, is that you know, if we had more memory, would we be smarter? Okay. If we had more memory, would we be smarter? And the answer is not necessarily. There's a fine balance. Okay. Imagine that I had the capability to memorize the whole book of mathematics, right? If there is a book which has all the math sums, like 1 plus 2 is 3, 3 plus 4 is 7, 8 plus 10 is 18, and I have this enormous amount of memory that I memorized the entire book, right? So what would happen is my ability to answer unseen questions will be zero. Okay. If that question is not existing in the book that I memorized, I won't be able to answer that question. So um, basically, at number of places, more memory becomes a big trouble. So and therefore, so, I mean, until proven, a bigger memory model could be worse or better than a smaller memory model. Okay. So yeah, with that we can begin this. This is very good question. What are the ways? Question from Sudhir is, what are the best ways to prevent hallucination in large language models? Good question, and good question to start with. Shall I go ahead and answer the question? I think let's go ahead and answer the question. These are pretty good questions. So you must have seen in ChatGPT or Gemini, when you ask a question, it is many a times it starts talking. Uh, I mean, many a times it starts hallucinating. Hallucinating means just you know, cooking up answers, names, things which don't even exist. Okay. I remember I was just researching on some paper and was trying to ask it questions, and it would hallucinate and would basically would even it created the fake names of the authors, fake URL of the paper references and everything. So yes. So one of the now this question, that how do I avoid hallucination? One is from the perspective of the model, and other is model trainers, like those who are training these models. Okay. And the other perspective is from the people who are trying to use them. So if you are trying to use these models, the way to you know, the only way to avoid the hallucination, the few ways to avoid the hallucination is, number one, when you are composing a prompt, be very, very clear, guardrail the prompt, give the complete expression. That is the first way, that you basically say explicitly that I have only this, these documents, do not talk about anything other than this document. So that is the guardrailing by the way of prompting. Okay. Now, the second is that once it has generated the utterance or generated the answer, what you can do is you can take that answer and try to see if it makes it is in the same context as what you have asked, right? And that you can basically check with you know, again using the ChatGPT itself or a large language model itself, saying that is this question in the same context as this? Okay, that is one way. The other way could be that you have a second model, you have a secondary model. What it does is it basically is trained on separating relevant and non-relevant answer. And basically you have trained it on embeddings of the text, and you have prepared this model after training it on, I mean, it's like a binary classification, classic machine learning model trained on the embeddings of the text. And you can utilize that to identify if the answer is very relevant or answer has gone haywire. Okay. So those are few ways to do it. All right. And if you are if you are, let's say, training and also avoid the hallucinations, one of the things you could do is keep the temperature to 0. Keep the temperature in the API calls. There is a parameter in LLMs which says the temperature. If the temperature is more than 0, right? If it is a positive number, the bigger the number it is, the more it picks up the random answers. Okay. And I mean, it is usually preferred in case of critical situations when you don't want too much of creativity. Stick to temperature equals 0. Okay. Um, Very good. Nice. So Eric's question is actually about the same point that I talked about. Wonderful. Wonderful. I think I did not have to prepare this talk. Instead, I could just open for the Q&A. This is a good question. So this is a very important question that Eric has asked. Question is, what is temperature and how does it impact creativity? And what is LLM creativity? Okay. So basically, creativity is just like with all of us, right? We do like when we want to give serendipity a chance. Okay. Let's say, be with me. Let me give you a good analogy that you go to a restaurant, you look at the menu, and based on the menu, you predict the, let's say, your preference of food. Okay. Like my number one priority is I will eat, I will eat noodles. Second priority is I will eat salad. And third priority is this. So this is your preference order, correct? So given the menu, you are predicting, given the menu of a restaurant, you are predicting the priority order of your choice, correct? Now, usually, if you are not creative or you are not giving serendipity a chance, you would always end up ordering noodles, right? Because that's your number one go-to. Every time you look at the menu, that's what it is. And I have met people who have the same thing, that they go through the entire menu and then they will order exactly same thing every day, right? Now, the other way of serendipity is that since you have prepared your priority list, pick something lesser than number one option. Okay. And that makes it creative. Okay. Similarly, in case of LLM, what is LLM? LLM basically takes your prompt as the input, and then it predicts which word to speak, the next word to speak. Okay. So when you keep temperature equals to 0, meaning no serendipity, what ChatGPT does is it picks the number one answer and then goes with it. If you keep the temperature a little higher, what it does is it picks the second answer or third answer, third word or fourth word, and then start with the prompt plus that word, and then that gives the next word, and it continues that same thing. So the instead of picking the top most predicted word, so basically what does a large language model do is that it takes the prompt from you and it gives under the hood when ChatGPT is giving your answer and composing an answer for you, it's calling the LLM many times. So it's basically taking the prompt, feeding it to an LLM, large language model, and this LLM is saying, this is the next word. And then it's taking that word and putting it along with the prompt, it's producing the next word, and it's going on and on. So if your answer contains 200 words, the model is approximately being called 200 times. Of course, it's way more than that. Um, I mean, there are multiple strategies to do it, but essentially the creativity or hallucination or the is controlled by this temperature parameter. And based on this temperature parameter, the chat GPT, when it's using the underlying LLM, what it does is it picks up the one that is giving the I mean, it picks up the low priority words as well sometimes. Okay.
Yeah. So to add to what you just mentioned, essentially think of it as the entropy or the chaos that you're adding to the type of probability that you are looking for. So if you are looking for a math answer, ideally you're keeping the probability or the temperature closer to zero because you want a deterministic answer, as versus if you're trying to write a fictional story, so you can jack it up to wherever you like, closer to one, which is a high temperature. So ideally, the amount of temperature is directly proportional to the entropy that you're adding into that, or chaos you're adding to that system, which increases the creativity of the model, but also makes it like hallucinate, right? So
yeah. So Bharat says that I am one of them, Sandeep. See the whole menu, but order the temperature equals 0 option. Nice, nice. Yeah. All right. How come I'm not able to add this smiley? Is it a way to add the smiley?
yeah, I mean,
Oh, got it.
yeah,
Got it.
I'm not able to add it either. Interesting. I'm able to uh add a smiley, but I'm not able to react to other people.
Yeah. Okay. Never mind. I think that option is not there in Zoom. Let's just start with the event. We have already started with a pretty good starting point. Wonderful set of questions. And I think, I mean, most of our audience today is impressively smart. So it'll be great to, answer everyone's question. And yeah, so perfect, perfect. Let's move ahead. Okay. Do you want to share the screen or? Yeah. So this is largely the agenda for today. We'll go over the backgrounds of speakers, and then we'll talk. We'll have questions around like what's the difference between the new AI and the older AI, and then we'll talk about the mechanics of LLMs, and we'll also talk about what are the current trending architectures, limitations of LLMs, and how do we handle those. And we'll also have the questions around deploying them, and you know one of the there are two common questions there. One is how three common questions. Number one is how do I build my domain specific LLM. Number two, how do I fine tune the model for domain specific situation? How do I secure the large language model? Or and third is how do I save how do I, keep my privacy intact with the model? So those kind of questions we'll answer. And but feel free to ask any questions. In case I'm not able to answer, I will let you know. Okay. But I'll try my best to answer your questions. All right. About myself, I graduated long back from IIT Roorkee. I have worked with large-scale computing, starting with D. Shaw. I mean, those who do not know D. Shaw, right? D. Shaw is the place where Jeff Bezos actually worked. Okay. And I'm sure Jeff Bezos, everybody knows. So at D. Shaw, the kind of work I was involved and worked at, it was basically large-scale computing, way ahead of its time. We had in 2002 we had the MapReduce infrastructure, our own kind of MapReduce, not like this classic MapReduce. We more have like we call it grid computing, run the script kind of thing. And we did a lot of machine learning. And yeah, though neural network were not to be touched at that point of time, we had a strong. I mean, at that point of time, though we like the team were experimenting at the on neural network, but mostly it was no because of not visibility, or you can say unexplainability. Now, afterwards, I founded a company, and then most of the power plants in India are built using my software. Then I worked with InMobi, where I processed 200 terabyte data to build the recommendation engine, and then I worked with Amazon product detail page, from which you do the buy now. That page was my ownership at Amazon, and then I started CloudX Lab. I really loved explaining technology and really enjoyed working on the technology. So I started CloudX Lab, and I've recently headed the AI for a company called Deborah. So feel free to ask me any questions. And yeah, over to you, Salil. Yeah.
Hey, so hi, I'm Saleo. I've been working in the conversational AI industry before I came to generative AI. And my journey into this has been as a product person. I started building products specifically for Majol. They are a large telecom giant, and we're trying to build CCAI agents. Have been working with all open and closed source language models, and have had the opportunity to learn from brilliant minds like Sandeep. So here to actually bring you our knowledge from the things that we're putting in production, from products that we're building in the industry, and enterprise products. So hopefully Sandeep can talk a little bit more about CloudX Lab, give the audience a little bit of overview over that, and then we can jump into our presentation for today.
Yeah. So I built CloudX Lab. I mean, not I, my team, and myself. We built the CloudX Lab with the single vision of upskilling engineers and professionals in deep tech, and have taught close to 250,000 people so far into machine learning, and I think since 2016 or so. And the thing that really is people find it useful is our playground, where you will see the playground on the right hand side, the content on the left, and it checks your exercises. And these exercises are related to machine learning, related to deep learning, related to the statistics, and so on. Now, the other part is that you have access to the console, you have access to the notebook and the file system, so you can do whatever you want. So the core idea is that this is a lab environment which you will find in any real organization when you join somewhere. So it gives you a real world experience, and it's seamless, so that you don't have to install this, install that, download it, download that. All the data sets are centralized. You can access it from any device, and so on. So we have lots of courses coming up, the executive PG certificate coming up, and then we have a course on generative AI coming up. So feel free to take a look at CloudX Lab. And yeah. All right. So that's about it. Salil, over to you. You want to share, or shall I continue to share?
Sure, I can share. No problem. Just give me 1 second, and
Okay.
I will share
It's
my.
okay, even if we don't share. I think I want to keep it more like less like a presentation or a talk, more like a discussion. And yeah.
Yeah, I meant to we can riff off of each other. Like it's a good segue. I think this is where I can jump in and ask you. Like AI has been around for decades. Let's like, I'm just gonna share my screen actually, if you don't mind.
Yeah, yeah,
Just
go ahead. Go ahead. Let me just see if people are asking questions on.
yeah, I'm checking there as well. Is my screen visible?
Just give me a moment.
No worries.
Yeah. This is starting to share.
Awesome. Great. No worries. And I'm gonna do a slideshow. So, AI has been around for decades. Chess computers were first able to beat humans in like the late 80s. I think Deep Blue beat Gary Kasparov, who was the world champion in 97. So what's different about this version of AI, and why should we be excited about it? Sandeep, what's your take on this? I would love to start with you first, and then I will jump on to my opinion.
Yeah. So I saw this, somebody's post or comment on my post, and then basically, and then I realized that the AI that was there earlier, like in 80s or before, most of the AI was like syntactical. Okay, like you have a sentence specifically specifically with natural language processing. People thought that if we can break down sentence into the noun and the verb, and we can parse it, break it down, and then translate each word, and we'll be able to compose. I will be able to create a translator, and that failed miserably. Okay, it never worked. So when they converted English text to Russian and Russian back to English, the meaning of sentences, meaning of the everything became completely different. So it has been, so that winter, the AI winter started when people realized that AI is not going to be syntactic. Okay, it's not possible to build a translator which does the word by word translation. It can't be. Now, this new era, I mean, afterwards, actually, people realized that what's going to be there is a model that learns by experience. Instead of people coding it, people have to build, we have to build a model that can learn by itself based on the data. The spam filter was one of the classic example, that instead of we coding and spam filter in email saying if it contains this keyword, then it's a spam and so on. Instead of creating rules by ourselves, we let the model learn the keyword density and other things, and then come up with a prediction whether email is a spam or not. So that's a machine learning way of doing things. Machine learning way of doing things is you train a model on the data and let this model do the predictions. It may not be predictable. The machine's output may not be predictable, but it would be for sure better than we coding it up. And that's a very thin line. And that's what is the big difference. When we are seeing hallucinations, when we are seeing all kinds of creative things, it is the result of machine learning from data and moving ahead. And that's basically the key difference is the key difference between the current scheme of things that have actually worked out is the machine learning from data. And then that problem, like though we figured out those basic models like SVM and other things long back in 80s, but the problem was we could not handle really, really complex tasks, such as language, right? We could not use the classic machine learning model on the language. Those models that we trained on the data, like a spam filter, were pretty naive. And that's why it's called naive Bayes, right? There's some like common model that people use. So, and people were experimenting. And then later on in 2012 or 2011, people started realizing that if we can build a machine which could do the fill in the blanks, okay, this is where a lot of like Stanford NLP and lots of other natural language processing system came into play, that they realized that we cannot do like the standard keyword density kind of a thing. Instead, we could do learn from fill in the blanks, take the big text and fill in the blanks. Because other bigger task in machine learning is gathering this data and labeling it. Take the data, label it. Take the data, label it. Right? That's impossible. And this is where the GPT kind of models came into play. Before GPT, I think people do not recognize or recall. There was this by Andrei Scarpati. He had published this Shakespeare. How do you create Shakespeare, right? And so the core idea was that given a text, predict the next word. That's all. It's like autocomplete engine that people are trying to design. But the problem was that these models were not really able to handle the context, the large context. And this is where a paper on attention and a paper on transformer, like attention is all you need, that actually showed that you can actually build transformer, build a model which can handle really long context by looking at each word over and over again in the context of the other words. And that started the entire era of large language models. And so I think what we have right now is much more creative and intelligent as compared to what we had earlier when we coded the deep blue. Deep blue was not deep blue. The chess player, that one was not really intelligent. It was like a coded rules. What was different was AlphaGo. If you see, when the computer defeated the world champion in Go, uh,
Yes.
for AlphaGo,
Lisodo.
that was machine learning. That was intelligent because AlphaGo learned by playing against itself over and over. And the
Yes.
kind of moves AlphaGo made were basically something that we never thought of. Okay. So we
Yes.
could never code for those kind of rules that we do not know. So, yes, the simple question is, can a human create an intelligent system which is intelligent than themselves? Answer is yes. But if you create it based on the data. Okay. It's a philosophical conundrum that can God create a sword which the God himself can't lift? Okay. Here, if you take the same philosophical conundrum in case of AI, the answer is yes, human can create more intelligent system than themselves. Okay. Yeah. I
Yeah.
hope that made sense.
It did, and I think you shed light on the fact that is not just AI has popped off in popular media just lately, but people have been working on it for decades, since like early 40s and 50s, and there have been like small summers or springs, but largely we have had AI winters. We have had like the pop off with Deep Blue, but the actual change came with AlphaGo, which was a machine learning model, which was not a logic based model where someone had programmed if this then that, but more of it had learned by itself. And like you correctly assessed and laid out to the audience, large language models build on top of a lot of we're essentially building on top of giants, right? So like the transformer model is broke it was a small domino that has like made big things fall, because what we actually solved was the natural language. Humans and language are so intricately involved that solving that natural language part of that equation has made a lot of traditional models obsolete, and this new set of models salivate, like technologists are salivating at the abilities of these new models, and the possibilities of them. But to temper with that, there's also concerns, right? Like in terms of like the consumption and compute power that is required to run these models. But you were saying something, Sandeep. I'm sorry, I might have
No,
interrupted.
I think, yeah. So yes, of course, large language models have made all other NLP models look really small as of today, and people are not going with classical NLP. But there is a very interesting part, and also most of the other systems are being improved as we speak. Um, for example, OCRs are improving because of this. Okay, and there are quite a few other things that are happening as of today, and we'll talk about this in more details. There's a question from Bharat. Shall we take that question?
Yeah,
Question.
that's the reason why like at the end of my thing, I was trying to talk about the consumption of it. So Bharat asks us about the concerns. Bharat has concerns about energy and water consumption of LLMs, and he recalls reading somewhere that LLMs consume a lot of energy as well as water. Please advise us about how to minimize AI resource consumption, especially that we are living through severe climate change. Um, yeah.
Correct, correct. So the concern related to energy is real. I mean, it actually consumes a lot of energy, but again, it consumes way less energy than any mechanical system does. Okay, any mechanical system does. Okay, and yes, but again, when you run them day in day out, the energy consumption is uh, quite high. I do agree with that. And yes, so I think yes, it does impact the energy consumption. Okay, but at the same time, I think that as if you compare it with a large factory, the entire of say Facebook training all these machines on the data would be consuming less energy than a large factory. Okay. Now coming back to the second question with respect to water consumption, water is not much consumed in the case of these models. Where is the water used? Water is used as a cooling agent, and usually basically we keep on circulating water and then cooling down the water and then again push the water again. So yes, it does require energy, efficiency, and there are like in chemical engineering you will study like there would be more and more innovations when it comes to the utilizing the heat of the heated water. But I do not think that it consumes too much of water. But at the same time, like many of the organizations are building these waterproof chips, which you can basically submerge into the water, and they basically run it there. And I think Azure and a couple of more data centers uh, are actually submerged into the sea. So that solves it partly, but yeah. So I'm not quite clear about the water consumption by the compute. It does, but I'm clear about the energy consumed is way higher. Yeah. All
Yeah,
right.
to address the concern that he raised, I agree that there are consumption challenges when it comes to electricity, but like any other technology, we as human beings will first audit whether it's worth that price, right? So uh, the power that LLMs unleash is internet, like all the text on the internet is somewhere to the it's in tokens it's like 10 to the power of 13, something like that, and I'm pulling this from Jan LeCun. This is not my own numbers. So I trust him to have done his math. According to him, what he's talking about is LLMs. The reason why they are so useful is for a human to read that amount of text, it would take 150 years, as versus, an LLM can do that in an instant, which is why it is worth us having such a power hungry technology out there. But obviously, there is we, again, like I was talking about before, we are building on the shoulders of giants. So all of these things that we are building, they there are people who are trying to solve like major problems, right? Like, so there's people who are trying to find nuclear energy. The people who are building the infrastructure are trying to make it more like affordable for energy consumption, for like water consumption, for everything. We're trying to make it more compute, or rather less compute intensive and more sustainable. And that's going to always be something that we as humans are going to strive for.
Yeah.
And the large companies are incentivized to actually drive the cost down. So be aware of this, that like all VC money is essentially going into large language models and the infrastructure for that. So we can rest assured that uh, the usage is not going to lead to something negative.
Yeah. But I honestly feel that there has to be a magnitude of improvements, because right now language is very small information. Okay. If you think about the number of photos that we capture per second, we capture approximately say 60 frame per second with eyes, right? Approximately 60 frames.
Yes.
And if you do that maths, you'll find that there are too many of too much of data that we are consuming and we're processing efficiently. Similarly, at the same time, if you think about the sound that we process in 1 second we receive approximately say like the eardrum would be vibrating 124,000 times in a second. Okay, so the numbers, if you see that the number of information that we're getting per second, it's just mind-blowing, right? And we are handling all of that. So I think we require, I mean, to go to like the way we are able to handle the language. If we want to handle the sound as well as the visuals efficiently and learn from it, we require tremendous amount of compute. Okay, and the current mechanism is not it. It needs to be improved a lot. Yeah, let's move ahead to the next point.
Yep. Let's move
Very
to the next
good.
one. So what are LLMs and why are they so special?
Yeah. All right. So at the first of it, the LLMs are basically, they are essentially like a autocomplete engines, right? When you are typing a message on your phone, the phone keyboard displays the next word suggestion. So LLMs basically is the children of that research. Okay, so we wanted to basically predict the next word given the sentence that has been spoken so far. And the beautiful part was that once this was built, only then people realize, oh, it can be fine-tuned. Okay, so there was a very good paper that said that actually led to the rest of the breakthrough. The paper said that large language models are quick learners. Okay, and essentially people found that large language models actually, even though they were just speaking the next word, next word, they kind of understood everything. They became intelligent. So this intelligence is by accident. It's not a planned intelligence. We never realized that this would lead to an intelligence, but surprisingly, it was real intelligence, because long back, I remember in 2013, like it was very clear that we can, like when we earlier, when people were doing the research, he was saying that you know uh, you need to learn the word and meaning. Okay, but when you think about it, none of us learned the word and the meaning, right? You did not. You learned the meaning of words by reading books. Okay, by reading fiction books, by reading Harry Potter, by reading all kinds of things. So you learn the meaning of words in the context and everything by reading it, not by following a dictionary. I don't think anybody ever followed a dictionary. Okay, I remember, even though I followed dictionary, but I don't remember anything that I learned from the dictionary. Okay, like the Oxford Dictionary, you remember? So basically the LLMs learned the meaning of things by just trying to predict the next word, and that has made it really, really intelligent. Now, the other advantage was that you did not need to create labeled data. It's kind of self-supervised learning. It is kind of a self-supervised learning in which basically we downloaded the entire the researchers at like who building this downloaded the data from the Wikipedia, New York Times, the entire of the internet, and basically GitHub code and everything, and we fed it. And interestingly, it understood everything. And that's how, I mean, it basically, we did not have to label any data. We did not have to label any data. Most of the intelligence has been built by itself by predicting next word given a context. So preparing label data was natural and did not require any human effort. That is what makes LLMs special. And also, the of course, people had tried creating large size of the models, but the mechanics that we were using were like the LSTM or recurrent neural networks were not sufficient to handle that large context. And this is where it actually worked. All right, let's move ahead. I hope I answered the question.
Yes, so there was a question in the chat. Camilo asks, how can we create apps with open APIs like or open source LLM APIs like Grok or Gemini? So Gemini is not open source. Gemini is closed source. It's a Google model, and Grok has been open source. GROK. It's the one by Elon Musk, and X.AI has recently open sourced it. And that's that's the perfect setup for the next part, which is how to build an LLM app, right? So let's do a breakdown at the high level. What are the steps to building an LLM app today? So there's 5 steps to building an LLM app. There's 3 phases to it. First phase is plan. So in the planning phase, what we are trying to do is identify a single problem to solve, right? So we are trying to figure out what is the application use case of this particular LLM technology. Then we're trying to choose the LLM. Obviously, for each use case, there might be a different thing. So let's say you're in healthcare. I think there's BioNemo by NVIDIA is something that was fine-tuned and created specifically for healthcare domains. So, the choice of LLM depends on like multiple parameters, but one of them is um, um, what domain is it trained on, right? Then you customize the LLM. Let's say you don't need to create like take a completely new thing. You can fine tune your own like a base model to fit for your use case. Then you set up the application architecture and conduct evaluations on the model to make sure that you are actually able to solve your use case, and you're building like a feedback loop so that you can keep improving your model. So this is it in short. I would love for Sandeep to add his 2 cents on this.
So basically so basically the LLM app would be So there could be, what you have to do is, right, there are, the way we should know is, like, first of all, what are the things that LLM produce? That is the first question. Okay, we need to understand, what does an LLM produce? LLM can produce a text. Okay, an LLM also has something called embedding. Embedding is nothing but bunch of numbers. Okay, like if you are trying to build sentiment analysis, right? So what you can do is, you can take text, compute its embedding, and then you can take the word like positive, take an embedding of this one, take another word negative, take an embedding of this, and compute. Consider embedding to be a data point in like multi-dimensional space, and compute the distance and see, is this is this review close to the word negative or close to the word positive. So basically, you got to understand the embedding, you got to understand what does LLM produce, right? So these two things, it can produce the text, it can produce the embedding. Now, once you are clear about it, then you can build all kinds of app. Let's say you want to build a sentiment analysis, simple. Take the like zero shot sentiment analysis is what you call it. Second, you can, you can build you know application by combining these two properties of LLM, right? The text generation and the embedding generation, right? Now, it can make your app to be part of other systems, or it can be sufficient for itself. Like, for example, let's say you want to build a custom SQL generator, right? Pretty simple. What you have to do is take the text, take the text. Let's say user asked a question, tell me the sales in last week. Take that question and ask LLM saying, here's a question from the user. Here are my tables and columns. Can you answer, can you generate an SQL for this? It will generate an SQL, execute the SQL on database and give the answer. So that's one kind of application. The other kind of application could be just simple thing like people are asking a question about your credit card. So you have created a constitution, a large prompt explaining what does credit card do and the limits and everything. And then you execute, you ask LLM, can you answer this person's question based on this constitution or this details about the credit card information. So, and then LLM can tell whether can try to answer that question. Now, the further thing is that you can build like a knowledge-based search. So knowledge-based search is in, you can take a question, let's say user is asking a question, you have to find out that article that is matching this question closely. So what you do is, whatever articles you have in your knowledge base, you prepare the embeddings of each one. Embeddings means the large language model will convert it into a bunch of numbers. Now you have kept all of these numbers, like the bunch of like coordinates of all the things. Now, whenever the user is asking a question, what you do is you compute the embedding of that one, then find whether this embedding, which article is closest to this embedding, and give that answer. Now, since it's going to be painful process to go through and compare each of the scanning through all of the embeddings, that's where you use the vector database to make this process efficient. And similarly, so what I'm trying to say is that depending upon the problem, you decide how can you utilize the LLM, and how can you do that. Now, let's say you're building a recommendation engine. Okay, how would you build a recommendation engine, for example, on top of using LLM? So imagine that your organization, imagine that you are running a company like Amazon, where you already have the recommendation engine, which is doing some amount of work, some amount of machine learning model, and so on. Now, by augmenting the description of the product, into the recommendation engine pipeline, you would be able to improve its performance. So convert, let's say, product details into embeddings, put that as feature to your recommendation engine, and then it will work. So essentially, all kinds of NLP tasks can be augmented with the large language models embeddings produced by large language models, and normal tasks can be just utilized. You can basically create a chain of prompts which basically can solve all kinds of problems. I hope I was able to answer. You're on mute.
Oh, yeah, sorry, I was on mute. Yeah, no, you absolutely answered that. And what I'm going to do is try and, dive deeper into these steps and try and help people understand. So, the step one is focusing on a single problem first. What's what I have seen, people and like teams, where teams go wrong is they try and solve all problems using, the most popular technologies. And I have a challenge with that, because sometimes, that you really don't need LLMs to solve every problem under the sun, right? So that I think, when you have a key, you try and put it in, all the locks that you're trying to
I
find,
mean, I
like
think
what.
I think the joke is on. It's like, if you have a hammer and you know only how to use a hammer,
Yep.
you will try to consider everything as a nail,
Nail,
and
yes.
that's a very common thing as opposed to what you might see. For example, for example, I remember one of the teammate coming up to me and saying, "Hey, my the can you come up using LLM? How can I improve improve the user experience of my page? The user experience is right." I said that, why can't you build a machine learning model whereby you will basically see the flow of users and try to predict which of the users will land where, and that will help you. No, 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 I want to do it using LLM. And I'm wondering, right? So LLMs are not great with your numbers. Okay, it's fairly hard. Okay, like for example, if you ask an LLM to you know multiply a three-digit number with another three-digit number, unless and until it utilizes the calculator underneath, the answer will be wrong. And that's the first test I always do when there's a new LLM. I usually ask it, what is 35.2 plus this? Okay. And you'll be surprised to know that it can't handle that, right? Similarly, yeah. So at most, what you can do is you can ask LLM to write code for you to solve that problem. That's the at most you can do, but the problem will be solved using different aspects. Okay, LLMs are great with handling language, but they are not very great with handling numbers. Okay, if you ask, let's say, LLM that, here is my data, can you tell me what will be, let's say, here is my data of the traffic on my website this year. Okay, what will be the traffic next year? Most likely it will just give you a garbage. Okay, and I saw this multiple times, like people forgot that you have to stop somewhere. Okay, and you have to, essentially, it can't, the large language models are not great with these calculations. Instead, what you can do is you can say, here is my data, write Python code to predict such and such, and then it'll generate the Python code, run the Python code, and give the answer. So that will be a better way. Yeah, go ahead, Salil.
Sorry. So for optimal experience, it is ideal that you choose a use case which is narrow. So for example, with the GitHub Copilot team, instead of trying to build something that is for the entire software development lifecycle, or like does the job of a software developer. They try to help coders finish coding functions in the IDE, right? So keep your use case as narrow as possible. That really helps you focus down and build well. Next is how to choose an LLM. So like choosing the right LLM for your use case is probably one of the most important decisions to make, and it is a difficult one to make because like someone was talking about earlier, Databricks will just release that like a couple of days ago. So there's this this field is fast evolving, and there's lots of new things that will keep coming on. So the onus is on the tech team to kind of keep testing all the models that are out there, have a platform where they can test their prompts, test their use cases, see what are the outputs, and run evals on these multiple LLMs to keep on auditing which one might be the best use for their scenario. So some of the factors to consider are, is your model open or closed source? What size is the model, right? But if model inference is something that you care about. So for example, Llama 2, it's much slower at inference as compared to Code Llama, right? So there are nuances, or even Mixtral. Mixtral is faster in at inference as compared to Llama 2. So there are, even for the same use case, let's say you are trying to make social media or marketing blog posts, both Mixtral and Llama can be used for that use case. Instruct fine tune. If you're trying to build that, you would want to evaluate your particular use case, not just based on the output, but based on the inference speed, right? Like how much time does it take you to do that? For, let's say, for trying to figure out how to write a marketing blog, it's not a big, like latency is not a big problem for you. But if you are trying to do something which is multimodal, or which needs the speed where your user is going to be there is going to be friction for your user, you would want to have those considerations. There's also privacy concerns where these foundation model builders use your data to train and improve their models, as well as ethical and other bias concerns. So pro tip here is make a comparison chart to shortlist and evaluate your options. Keep updating it regularly. You can list models based on their size, costs, performance, risks, and deployment methods.
Yeah. One thing I want to add here
Please.
is that one of somebody said that, okay, since the OpenAI is charging too much, why don't I host my own model? Okay, the answer is that when you are using or hosting your own model, very important part, right? You have to keep the model loaded all the time and running and up and running available, correct? Which means if you, let's say, take up a cloud and specifically with GPU running like 24/7, the cost of that one is going to be way higher than what OpenAI charges you. So that's one important thing to keep in mind, that it's not like if you do the on-demand version, let's say whenever there is a question, only then you load the model and do the inference. That will take probably uh, maybe say 2 minutes minimum, 2 minutes minimum. It could be more than 2 minutes actually. On a normal computer, it'll be like 30 minutes to load that kind of model from disk into the memory and stitch the entire thing. Okay, so remember that most likely you would like to keep the model loaded and keep it running. Otherwise the performance, the user's query will take a long time to answer, and you cannot use that way. Therefore, cost, I can guarantee that I think the kind of cost Gemini or OpenAI has, is way more reasonable than what you will pay to your cloud service provider.
Absolutely. And to add to that, I would also say, take a look at Claude. I was very surprised. Claude, it's the smallest model. I'm drawing a blank. Uh, Claude Sonnet. Claude Sonnet is a multimodal model, which is extremely cheap and really, really fast. So its inference speed is great. You can use it for specifically, like, like let's say you are trying to describe a visual. It's great at converting images into text and annotating those. So again, depends on your use case and what you're trying to build with that. But lots of new models out there, really affordable, better than again, I think this is a good segue into talking about like fine tuning as well as training your own model. But I think we'll come back to that in a little bit. Let's talk about because we are talking about how to choose an LLM, let's talk about the limitations of LLMs, right? So I'm just going to talk about some of the limitations, and Sandeep can add more color. So one of the biggest and the baddest ones that we've all heard about is hallucinations. I also am like very intrigued by the way they've worded this, because this is usually computers is it's calculators. They're like black and white, but we are using very anthropogenic and like human like words, which is like hallucinations. We talk about human beings, but again, the word is being used so that they can package this technology as something more than that what it actually is. But it also encapsulates the problem that is caused by this technology. Most computer solutions are black and white, right? 2 plus 2 is always 4. That it can't be anything else. But with LLMs, there is this possibility of it coming up with just infactual or rather untruths, right? But I think Sandeep and I have had this conversation before. We both look at it as a feature rather than a bug, because it's almost like human creativity, right? Like humans, when we are thinking about fictional things, when we are trying to ideate, these are in certain ways, dreams are a way of hallucination, right? All of these things give us the ability to then imagine things that were rather benign or not possible before. So the hallucinations is a big problem when you're trying to make sure that your answers are factual. Another point is that these training, there's training cutoffs. So things are frozen in time. So these large language models do not have the most up-to-date information. And ChatGPT is known for this, like, oh, my training cutoff is back in 2023. I don't know things from right now. So that's another challenge with this. The next challenge that was there in earlier 2023, which is not so much here in 2024, and Sandeep can talk allude to this when he adds more color, is the problem of limited context windows. So context windows were really small to begin with. They started at like 1024, went to 2048. When ChatGPT came out, I think it was 2048, and then it went up to 4096. Now it's like 128K if you are paying for it. Gemini has gone up to like 1.5 million or 1 million tokens. So those problems might be getting solved, but again, that is a limitation when if you're trying to use open source and smaller models. So those are some things to be considered. Also, another one of the limitations is bad scaling with increased context. So again, for smaller models, the longer the context, the harder it is for them to figure out. One of the eval tests for figuring out, the quality of a model to figure out within the context window to pick out a certain thing is something by Greg Camrat called needle in the haystack eval. So that's something that you can run on your own to try and figure out how good is the model that you're trying to use on that particular metric. So
I want to add something.
yeah, please. Like I did want to, leave the bandwidth numbers to you because you've
Okay.
had experience with that yourself. So please touch on that.
Yeah. So other than these limitations, right? They are bad with numbers, they are bad compilers, they are not very good with, wherever there's a concrete answer to be given, they are bad at it, right? Just like, so now question that comes is like, what else is the problem? There is one more problem that we have not mentioned here. One of the problems is that since LLMs produce one word at a time, producing text is going to take a lot of time. So one of the complaints that I get from my engineers usually is when they're newbie, that this LLM is taking 10 seconds to produce an answer. Okay. And when I ask them, like, can you see how ChatGPT is fast? Then they realize that ChatGPT looks faster because it is producing one word, it is streaming the outcome. So when you are putting it in production and you are waiting for the entire answer to be computed, you have to be mindful of the fact that underneath it is producing one word or one token at a time. Okay. And it's again and again feeding. And this cannot be parallelized. You might say that, okay, we can do the parallel in future and so on. This can't be parallelized that easily because producing the next word requires the previous word, and therefore it has to be sequential. No matter how many machines you deploy, there will be time delay, the time taken for producing the outcome, and therefore you have to be mindful about this fact. While you're designing your system, you have to show some progress to the end user so that the end user is not waiting forever. That is other than being bad with numbers. So now here, how do we solve these things? That is another question that would be coming up by people. So, right. So to handle these situations, we have many architectures and solutions coming up. One of the most popular one is retrieval augmented generation, right? Since the context size is a limitation, like for example, you have country's constitution as very big, and when you see a question or a problem related to a particular particular aspect, instead of referring to the entire of the constitution, you may want to first find out which is that page in that book which talks about the current situation, right? And for this, you basically use the ways of searching or finding the semantically owned systems, right? So basically the to handle it, we basically do this. We augment the question with the context. Okay, we put, when we are asking ChatGPT that can you answer this question, instead of giving it the whole of the constitution of a country, we just pass a page or a two pager along with this, and then the ChatGPT or LLM can answer in that context. Okay, this technique is called retrieval augmented generation. Now, retrieval can be based on syntactic or semantic. Usually, syntactic means based on the word search, but that's usually useless. A better technique is that convert the question into embedding, convert all the documentation into pages and break it down into pages. Each page you have the embedding, and when the question comes in, find out which page it belongs to by finding the distance between the embeddings of the two embeddings of the knowledge base and the question. And that's how you do the retrieval. To make it fast, people use the vector databases, and that's it. Now, there are fine-tuning techniques. So yeah, yeah. Now, one of the questions you have is fine-tuning. One of the questions that I keep getting is that I want to build a LLM that can talk on my data. Can I fine-tune my model on my data? Right? So the answer is it doesn't make sense, right? So can I fine tune, as in, can I retrain the model? Can I retrain LLM on my data? The answer is no, you cannot retrain the model. In past, I have tried to retrain a model on my data, and the more I retrained, the dumber it got. Okay. It kind of capped on becoming more and more stupid. It could not, it basically, right, you ask it anything, it just gives the answer in the same way. So even though we burnt a lot of money in retraining the model on our data, and we were thinking that our data is sufficient for this kind of thing, but we were wrong, right? The retraining a model on your data is not going to yield great results. The answer is augmented generation. Augment the prompt with your detailed, context, and you get great results. Now, you might think that, okay, we would train your model from scratch. That doesn't make sense again. When fine tuning doesn't make sense, this definitely doesn't make sense. What you can do instead is that you can take a good fine tuned model, freeze the entire model, and then make a special purpose models, like compute the sentiment analysis, do the sentiment analysis. Like, for example, you have the data of Amazon reviews along with the ratings, and you want to build a model which can exactly predict the rating precisely. So what you will do is you will have the model, put couple of layers on top of it. You take a LLM, that's the foundation one. You use this model to convert all the reviews into embeddings, and take those embeddings, create another model, and train that model, and that's basically would do a better job. Okay. So I think a very misnomer word is fine tuning. Sometimes people just say fine tuning in the context of improving the prompt. Sometimes fine tuning means retraining the model, but here I'm strictly using fine tuning as a phrase for retraining your model. So retraining your model doesn't make sense, honestly, but
Absolutely.
composing a model using embeddings makes more sense as compared to anything else.
Can we talk about what use case would there be where it's valuable, or you find value in fine tuning a model?
So fine tuning the model is basically like, for example, you have just trained a LLM to predict next word. Okay, you want to polish it. Okay, you want to polish it, like, instead of being toxic. Okay, let's say your model is very toxic in nature, so you want to basically give it more human fed, human composed question answers to make it more rounded. Just like, you know, you learn to run, jump, and do everything in childhood, right? But you are being sent to a finishing school to just, get those, socially acceptable etiquettes in that context. So
Absolutely.
fine tuning model is like that. Like, it's a very fraction of condition, but again, you have to have sufficiently large set of Q&A to even do the fine tuning. Okay.
Makes sense. So you have to have a sufficient amount of data to be able to fine tune, first off,
Yeah.
which is costly, and then there's like compute and money and infrastructure required to actually do the fine tuning. But like you mentioned, there are the use cases for fine tuning would be, let's say you're trying to remove bias from the output, or you're trying to fine tune for toxicity. Reducing toxicity and bias can be help. Like there's a technique called DPO, which is direct reference optimization, which is used to reduce toxicity and bias in language models, language model outputs.
Yeah.
There's also parameter efficient fine tuning, which can be used. Again, what the use case, as Sandeep mentioned, is think about it more like, let's say you want your, you have your base model, you want to look at its model card. You want to know what it is already been trained on, what has gone in its training data. So is that already existing in its understanding and its, let's call it world model, or its understanding of the world? Is that already present in that model or not? If it's not present, so let's say we are taking a base model which is not fine-tuned on healthcare domain, and we are trying to use it for the healthcare domain. We want to give it lots of data which helps it understand the vocabulary and the kind of format that we are expecting from it as humans, and then we are going to fine tune it on that particular domain. That being said, there is the use cases of this are limited, and there is better techniques with like advanced RAG, as well as advanced prompting techniques. And I would also like to add, like Sandeep mentioned, that if you're changing the prompt, if you're optimizing the prompt, that is not fine tuning. That is prompt tuning, or prompt engineering, whatever you want to call it, but not fine tuning. Fine tuning is actually retraining the model weights and getting something else out of it, so that it the person I mentioned before, Greg Cameron, another brilliant mind, what he had done is he tried to do research on if we can give a particular kind of a voice and a personality to the kind of outputs that we would do, getting out of them. So there are use cases where these kinds of things are useful, but mostly not. Training your own model from scratch, I would highly advise against that, unless you have billions to drop. And even if you have billions, like, I don't know if you guys heard about Inflection AI. Sandeep, you probably heard about this, right? Inflection team entirely got Aqua hired by Microsoft, and they've now created their own thing called Microsoft AI. That team had like multi-billion-dollar funding from like Reid Hoffman, from Bill Gates, but they had to stop making their own foundation model and go like with Microsoft, because it doesn't make sense to have too many cooks trying to make these big foundation models. So yeah, that's just my 2 cents on this. To you, Sandeep, and to the next. So yes, the next question is, there are privacy concerns about the data being sent to LLM providers, right? So there's two parts of it. One is, I'm just going to go back here, is like, first off, there's hallucinations, being frozen in time, and limited context size windows. These three can be solved using retrieval augmented generation, right? So retrieval augmented generation essentially lets you query or talk to the LLM models based on your own data, grounded in your own data. So it's giving you closer to what you are expecting from it, what it might not have been trained on, and it will give you those insights by itself. Now, when it's doing that, there are challenges, because sometimes there's two types of data. One is structured and the other is unstructured. Structured being SQL databases and databases of that nature. Unstructured being PDFs, audio, video, whatever else that might be. So when we are talking about our own private data, which the LLMs should not be known are not trained on, and should not be trained on, let's say it's IP. So how are we going to mitigate these privacy concerns about data being sent to LLM providers?
Yep. So yes, I mean, this is a very important part. So one is, so you have your like, it is very clear that I mean, it's fairly hard process to deploy your own local model, and most likely you would end up with one of the large language model providers. Now, the first thing is, go through their policy. They usually have, I mean, OpenAI and other people, they have an agreement. If you are going for a professional license, they would not use your data in any way. That is first thing. Second, try to reduce the amount of data you are sending to them, right? You can essentially, why do you need to send the data to them is essentially, in a particular context window, you have to provide the information. if let's say you're building a SQL based model, you don't have to send the actual data to them. Instead, just send the information and let them generate the SQL and you execute it locally. So first is go through their documentation and see their terms. Number two, see how can you minimize the data that you are sending to them. Okay. Third is third is uh, third is learn about named entity recognition. Okay, so take your let's say your question. Let's say you are having a metadata information, and other. Let's say you are having a prompt, and you want to remove or replace or mask some of the names and entities. So a common technique is that you identify the entities and use a local model for generating similar data. So there are quite a few models available for generating data, and you basically mask it. Instead of saying Sandeep Giri, it'll be Sanjeev XYZ or something like that. So it'll basically replace all the important names and numbers with similar numbers nearby. And it's up to you whether you want to replace numbers, names, year, and all of that. So there are quite a few powerful NERs, named entity recognitions. Models have become really, really good in recent times. So you can mask those keyword, personally identifiable information, PII. You can replace it, mask it, and then send it to the LLM, and that's how you can control the privacy. Also, when you are dealing with an organization, right? Also have your local data classification in place, right? So, like for example, many of the organization have the best practices in terms of labeling local data as a P1, P2, P3, P4. P1 is nobody has the access to the data, not even your server. Like for example, password of the user, not even server has the information. Then the second one is the credit card. So nobody has an access to the credit card other than the database. That too, it's encrypted in some form, and so on. So you should classify your local information into these labels. And while sending to LLM, be very mindful of those privacy labels. All right. I hope that answers the question on this.
Absolutely, absolutely. And to add to what you were just talking about, uh, so named entity recognition has been around since a while. LLM, so like one of the use cases is, because you talked about an PII, like one of the use cases that comes to mind was trying to build the contact center AI for this large enterprise telecom company. And the customers are in EU. So there is GDPR rules. There's like, lots of different kinds of policies that you have to make sure that you're in compliance with. And what we found is to retract the PII data, we used a local LLM, to like local LLM based in on infrastructure in the EU, to then redact the PII, send it to the next LLM, which does the translation, and then is sent to another agent elsewhere outside. So it's all done. There's lots of use cases of how you can use and leverage LLMs and named entity recognition models to mask and take out not just PII but other entities that might be concerning for you to share with these large language model providers, and they can be handled in a lot of different ways. So this I'm just being cognizant of time. I'm seeing some questions pop up. So what I will do is we'll just take the last few questions and then we'll wrap up so that we are not going over time. So Sudhir asks, which LLM has edge in terms of privacy and security of data? So you know,
Okay.
yeah. So like before I hand it off to Sandeep, just to add, you know, like Sudhir, if you can add us, like give us more context about what is the use case that will help us, you know, cater our answer better.
Yeah.
But yeah,
So
so we'll.
I think we have already answered the privacy part of it. The security part, I think we are going to talk about a little bit more. Okay.
Yes, yes.
Question from Sudhir is where does few shot model fit in these solutions? So basically, few shot learners, when we say few shot model, basically we look at the same question over and over again, and that's about it. Okay. So do you want to add anything, Saraj, to
Yeah, so I would say few shot is a prompt technique more than a model. And what we are doing in few shot prompting is giving the language model examples of the kind of output we are looking for. So the prompt as well as the output. So the, let's say prompt is the question and the output is the answer. We want like multiple examples of question answer pairs to then give, so that when we ask a new question to the language model, it understands in what format it is supposed to give its output. So that's what I would talk about, you know, few shot prompting. It's not specifically its model by itself. There's models that are few shot chain of thought. There's lots of different prompting techniques, and that's, you know, that can be another talk of its own, and we would I think jump into that the some other time. But I think in cognizance of time, having looked at how important the RAG architecture is, the next time to cover would be failures of the failure points of RAG systems, and that's what we will touch upon because. As we've understood, like we can see that there's massive importance in RAG, and RAG is all the rage. There's lots of different problems that are being solved. So hopefully we get to see that. And following the failure points of RAG systems, we will have a deeper dive. We'll take like the next session after that. We'll take a deeper dive into how to build an enterprise RAG system. So all the different components that might go into it. How was it being done in 2023? How our enterprise is doing it in 2024? And like always keep in mind that this is an extremely fast evolving field. All things are, you know, a suggestion, and if you guys have more information and, you know, insight to add, please, we are here to learn and share our insights. Feel free to do the same. Sandeep, if you want to add a last few words.
Yeah, I think yeah, nothing much to add here. Yeah.
Right. So with that, if you
No,
guys
we
have
can
any
go
other
back to
questions.
we can go
Yeah.
back to the SQL part. So I
Oh
think
yeah.
yeah. So
So
yeah, we can just talk about this one very quickly.
yes.
Now, very important part to understand is that how do we build it build to solve a complex problem? Well, like keep in mind that LLM can generate prompt for itself. That's called recursive calling. You can use that. Second is you can interact with various kinds of database systems. So you can ask an LLM to create SQL query, talk to the database. You can ask it to generate Python code and execute that Python. You can ask it to generate Python code for visualizing data, Python code for training data, training on data, and so on. So it's like just like you will ask various engineers to do various things, you will do that. So I think with this knowledge, you can essentially build really complex, system that can solve all kinds of problems. Yeah, next one you can go. One of the things that I want to talk about is the when you are, there is a very common thing that is going around now is that you can actually, the LLMs have become really good at generating SQL. So you can answer your customer's question based on the data. Like, for example, if you are Amazon.com, you can just take the question of the user and generate the query, SQL query, and let that query be executed, and it can answer. So, but the problem is the security. And for that, I have built this LLM SQL sealed, using which you can essentially create subspaces per user, and you can basically secure your data so that you can run user's query in only the context of the user's data. This is very useful for people who are trying to build SQL based or who are trying to answer questions based on the structured data. So feel free to take a look at this. I would love to see your feedback on this. And yeah, so I can just share. You can share this link with everyone. Got it. All right, I got it. Thank you.
Yeah, so
All
I've
right.
shared it here, and I'll also add
Thank
it.
you.
We'll also add it to the LinkedIn and YouTube description so that people can.
Yeah. So that's pretty much on my end. If there are any questions, I would love to answer. Salil, anything else you want to add?
No, I think that's it from my end as well. I don't want to make. I am sure people have their days planned for themselves, and I don't want to take too much time from them. I would like to add that the next event that we're planning is 7 failure points of rack systems, and the one after that is specifically about how to build enterprise grade rack systems so that you can put rack systems in production. And I think there's lots of people who have questions about this, and hopefully we can answer and address their questions. If you have any questions, you can feel free to reach out to us on LinkedIn or drop a comment on any of the social medias that we've got. Thanks so much for your time.
Yes, Vijay's question is yes. Are there free models? Yes, I think they offer some amount of free quota. Just give it a shot. It's not too costly. Also, it's just like a couple of dollars. I think. Just
So
give.
yeah, so Vijay just asked, are there any free models? Are there any models that have free API usage? There's lots of models on huggingface.co. I think so. Hugging Face. Just go on Hugging Face. There's lots of open source free models that you can use for inference. And I think if you have a new account with OpenAI, they should give you $5 in credits. If not, try and like use a new email and create an account. But I think they have ways to get around making sure that they're not being milked for money, but try your best. There's also lots of models from open source models from like Mixtro, Grok. There's DBRX by Databricks. So there's lots of free options. If you're looking for closed source models, that's where you might have a challenge. But yeah, if other than that, I don't think I have much to add.
Yeah, thank you so much, everyone. Feel free to reach out to us and yeah, join me at CloudX Lab in my upcoming course. Thank you, everyone.
Thanks, everyone. Bye.